Hello everyone. Today we will see the column design, uh, which is subjected to moment and to 50 moment. So let's see the question at first. At first we can see here the design of the 8 stories building is column moment n 250 kilonewton per meter and given figure. This is our building, which is 6 meter, 6 meter, and 6 meter, and in extension and white is one is 5 meter, 5 meter, 5 meter of the slab panel. So we will design this column, and this is the 6-story building. So at first, if you want to know how to get 250 kilonewton per meter, and how we will get this value, this is actually given in question. But if we want to find the value from real exam, from real field, then we have to calculate it from portal method. We have to analyze the portal method. This is value comes from the wind load, or this is the value is come from wind or earthquake load or lateral load also. So we can see the wind load or earthquake load. The value is comes from here. This is the another example, but I will seeing how we will get the moment value here. So wind load is subjected to in this building. At this analysis, we have found the pressure 4 kilonewton per meter. Here is the another example we have found here, and wind force we have calculated here 4 meter tributary area, and the value is found like this way: 52.8, 52.8, and 26.8. And we have divided this BV to B, and this is the portal method example. And 2B equal to 55.57 kilonewton meter, and B equal to divided by 2, as we have calculated the internal column. And the moment will be B divided by column distance. The column height is a 3.3 meter, 3.3 divided by 2, and get the moment value. This is the actual procedure how we will get the moment. If you want to how we will calculate wind force or earthquake force, then we have to go the another example, which here is the example of wind load. This is the wind pressure, and we have got the wind load here. All the load is here: first floor or 10 feet and 20 feet, 30 feet. If we want to increase our height, then the value will be also increased. So this is our value. So this value is found from wind load calculation. So if you want to see at first we have to calculate the impact factor and alpha, beta, kz, kd, b, gl by b, and cp leeward, cp windward, and we will finally use this formula for pound per feet square. Q equal to 0.00526 I kz, kd, and b square, and then we'll get the pound per feet square, and we'll use pz and kz value, and this is our box. Then we'll get the value. This is the procedure to we'll get for the wind load. In the same way, this load we can found this load or wind load, this load. In the same way we will get the earthquake load here. In the same way we will get the earthquake load. Here is so we have to calculate the earthquake load in the same way. So if you want to get the earthquake load, so we have to calculate the same way. So let's see, we'll get the earthquake load. This is the another procedure of to get the earthquake load. Here is the earthquake load. We have to consider seismic load and impact factor, site class, and response reduction factor are and taken from one BNBC, and you can take this value from ASA 705 or 07 or SA 318 or other civil load, and seismic S1 S2 parameter, and we'll get S1 S2, and soil classification SB, and get the FU, FB, and in the same way we will get SD and SD calculated. So we will get the SD 1.36, and in the same way we will get the T CTMA2, and then we will get the SD1, the time factor, and spectral response oscillation, and we'll finally we'll get the phase shear. This is our final ultimate phase shear. C is equal to 0.4 into F2. This is our B. The value we will use here is B. Then we will calculate the in Portal method. Here is the Portal method we have found here. Portal method. 18 value is found from wind load or earthquake load, and we will divide it this load in B3, and internal column will take the 2B, and in this way we will get the B, and then if we get the value of 3, and we can calculate here moment. What will be moment will be B into H by 2. This is the B, so B will be H by 2, B into H by 2. H equal to 10 feet divided by 2, so it will be 3 into 10, 30 divided by 2 into 15. So this is the 15 value. In the same way, this is the 13 will be here. 6 into 10, which is 16 divided by 2, which will be 30. Here is the value of 30. This is the column moment diagram of column. So we will get this value in this way. Subject to however, I have clarify here how to get the 250 value. So let's go for the calculation. The step 1 calculation, that load equal to self weight of slab, floor finishing, end domain, and number of stories. Okay, so how we will get the self weight, volume, and unit to end, and number of stories, and thickness, area of unit to end, and number of stories. So this is the 250 is the thickness of slab, and 5 into 6 is the tributary length. Here is the 5. Here is the column. The column is subjected to 2 spanel, 6 into 6. Here is the 6 by 2, 6 by 2, which is 3 plus 3 into 6, and here is the 5 into 5, 2.5 into 2.5 into 5. So our tributary area will be 6 into 5. So here is the 6 into 5, 25 into unit weight of concrete, and 80 is the number of stories. Okay, here is given the number of stories. And for floor finishing, the thickness of floor finishing 0.05 meter, and 5 into 6 into tributary length, 24 into unit weight, and 80 into number of stories. In the same way, random wall, 3 km per meter. This is the kilometer per meter square is the taken for ACI 318 or ASC 705. 5 into 6 into tributary length, and 7 into number of stories. So we have found the dead load 2358 kilonewton, and live load equal to loaded area into now live load 2 kilonewton per meter square is taken from the code ACI 318 or ASC 705 or BMBC or other local code. 5 into 6 is the tributary area we have seen here, and 80 into number of stories. So 480 kilometer meter. So design load 1.2 dead load plus 1.2 of live load, which is 3598 kilonewton per meter, and we will assume the column size which is 0.65 into 0.80 0.85 FMCHE. This is only for concrete. We can assume that concrete will be taken the load only. That is, we have not considered any steel will take the force. That's why we will use only concrete. And we have found 33917 which is 583 and 583 millimeter square. This is our initial assumption of the column size, which only take in the concrete force. Okay, so let's calculate the steel with steel. T prime into covering phi of tie bar minus phi of main bar divided by 2. So we will calculate actually here d prime. So 25 is the covering to 25 here to here covering, and 5 tie bar. Here is the tie bar we have used 10 milli, and the main bar we have used the 20 milli, and divided by 2. So d prime equal to 45 millimeter, and d, what will be d? The d will be h divided by d prime. So d will be here is the h equal to full height, and there is the d divided by d prime, and it will be 538 millimeter. And d by d prime, what will be d by d prime? D is here minus d prime, so d minus d prime. So gamma equal to 2d minus d by minus to h. So the value will be 538 divided by 538 into 538 minus 0.45 divided by 538. So we have found the 0.85. So our column interaction chart will be 0.84. Here is the 0.84. So there we have used 0.70 as we have not found here, but when we will see, when we will calculate the practically, then we will use the 0.85 graph for interaction graph. Okay, so Ru equal to Pu E into 0.85. Oh, so the line will be equal to M by Pu. So M equal to 250 we have found question given in question, but we will actually found from earthquake and wind. We have already shown how to calculate it in a briefly. So the value will be equal to 0.06 m, and the r equal to pu m equal to f prime s g into h. So we have put it all value here and found 0.0803. The r value 0.0803, and k and equal to p equal to 5 fm h. So we have found the 0.678. So 0.083 r, here is the chart we have found. R is x direction 0.083 here in the red mark, and k and equal to 0.678. 0.678 here is the red mark. So our interaction diagram is here, so is less than 0.01. So the from we have found the rho value is 0.01, which is less than value. So we have to reduce the column size. So at first we have here we have assumed the 538 by 538 millimeter square. Now we will reduce the column size. So in the second trial 1, the assumed column size 483. We have reduced the almost 1 milli, because we have at first we have assumed 583 into 583. Now we have calculating 483 by 483. So let's see how we'll get the value. Rn equal to 0.18. Here is the r value is x direction for it is a green color. Sorry, it will be gray color. And k and equal to b equal to f times c, which is 0.098. Here is the gray color 0.098. So 2 points are intersect at the 0.03. The rho value will be 0.03. So rho value is 0.0733 from graph, and so 1%. It is greater than 1% and less than 8%. Less than 8%. So our desire, this is the most challenging part to get the rho value, but we have got the rho value, which is 0.003, and A is equal to rho BD. So our steel will be 8795 millimeter square, and we have used 10 millibar. So number of bar will be as divided by as. So we have found the 18 bar to be used. So 18 bar, here is our dimension of the column, and 18 bar will be used here. 28 into 28 bars in 20 millimeter by main bar have been used here. and spacing of the tie bar will be by this formula, which as you can do 80 into dt die of tie bar, which is 480, 16 into die of main bar, 16 into 20 320, and at least dimension 480. So therefore 320 is less value, so the 10 milli tie bar will be use 320 millimeter center per center. Here is the detailing of the column. So this is the our example mm, of the column design, which is subjected to the moment. If you have any question, then ask me. I think I want to say that we have assumed the value 583. We have at first assumed the 583. This is not an exact value, because we have considered only concrete is taking all the forces taking the concrete. There is no steel will be participate to take the force. That's why we have just assumed 583. This is the first trial, and for the second trial we have reduced this value, as the rho value is very low. Our rho value should be a point between 0.01 to 0.08. Then we will calculate or find the value of s, but we have found here the rho value 0.01. Here is the first trial. That's why we have reduced the for second trial the value of column dimension 483 and get the desired rho value 0.03, which is 3% almost. So and got the steel area and number of steel. So this is my lecture is in here. If you have any question, please write here. Thank you.